over. Oops, what am I doing? Okay. Oh, let's turn the Elmo on. My goodness. Here we go. Okay, so remember with K expressions, it's products over reactants, always, always, and it's what you have when they've reached equilibrium. And remember, equilibrium means when you have the rate of the forward reaction is equal to the rate of the reverse reaction. And solids and liquids are omitted from that equation. So your Kc for this is products over reactants, but your reactants is solid. And don't forget, you need to have brackets, not parentheses, brackets, because that specifically represents concentration. Kp is undefined because we don't have any gases. So for Kp, it's gases only. For Kc, it's aqueous and or gases. For the second one, that was balanced. Make sure this is balanced because that's gonna, well, I guess this one it worked out. But so there it's balanced. Solid, solid, gas. That's the only one represented in your equilibrium expression. So your Kc is the concentration. Your Kp is pressure subscript O2. The next one, we're actually crunching some numbers. So this one was based off of this reaction. So you get your equilibrium expression, which we have here, and make sure to go in Kc, it needs to be in concentration units, which are not just moles, moles over liters. So you got to get the concentration of each of them first and then plug them in. And Ks don't have a unit. 2 sig figs, so around that to 2 sig figs. This is a very tiny K, right, to the -20. So that means your reactants are heavily favored. And in this case, reactants, this is when it dissolves, right? Soluble is the products, breaks up into its ions. Its precipitate is the reactant. So now we're kind of adding all these different concepts together. We have a small K, which means this side is favored, right? Your denominator. And your denominator is a solid. So based off your calculations, would you expect AgCl to be soluble or insoluble in water? I would predict insoluble because my K is way less than 1, which means your reactants are favored and my reactants are a solid. Any questions on our little first step into equilibrium? All right, let's look at our PowerPoint then. Yeah, let's do that. Okay, so switch back. Make sure you bring your pre-lab today and something to write with. I will have a copy of the lab packet on the table when you walk in. If you're session 1, you're coming to the science building and they'll take your temp, ask you questions. You'll grab your packet downstairs and come on up, something to write with, grab some goggles, and then just start making. We're going to go over the pre-lab before we start. And I have all your stuff there. I'm trying to think anything else I want to say. We'll go over the pre-lab. The first thing then would be making your solutions, calibrating your colorimeter. We'll talk about the wavelength in our pre-lab. And then take the absorbance of each of your solutions. Great. Then you're going to do your crystal violet and base together in the cuvette and just let it go. When it's done, drag the data over, clean up, and you're good to go. Okay, so share screen. Here we go. And let's do this. Let's do this. Come on. Slideshow. All right. So we really just talked about what is equilibrium. Concentrations aren't the same. They're constant, though, once they reach equilibrium. And no matter what you start with, products, reactants, however many, they're always going to reach equilibrium, which means the rate of the forward is equal to the rate of the reverse. And then on the worksheets tonight, you might have enough to solve for Kc, and it's asking for both. You use this equation to convert between the two. R is the gas law constant. Make sure your temp is in Kelvin. And then this is your difference between your moles of gas minus your products minus reactants of just gases. Hence the big numbers in front. Okay, so here we go. What does K mean? All right. Nope, we did that. That was saying aqueous and gas only. Here we go. Okay, so on our worksheet for number 2, they said, hey, at equilibrium, here are your concentrations. Great, we can just plug them on in as long as they're in molarity. But we don't always have the equilibrium concentrations when they reach equilibrium. We can do some predictions. If we know how much we're starting with, we can predict how much we'll get at equilibrium based off something called an ICE table. So our note today is really just working through this problem here. So in a closed system, I'm going to show you some keywords here. In a closed system, initially, so that means it has not reached equilibrium. That has just started. Containing 1 molar, starting in molar, great, of H2 and this much molar of I2 at this temperature is allowed to reach another key, equilibrium. These words to me tell me these are not at equilibrium. So I'm going to have to do something called an ICE table, where I'm going to take my initial concentrations and do something called an ICE table to predict what are the equilibrium concentrations, and then I can plug them into my products of reactants. To plug into your products and reactants, they have to be either molarity or gas units, and they have to be at equilibrium. This is telling me, okay, actually, let's do this. We want Kc. The analysis of the equilibrium mixture shows that the concentration is this. So when it's at equilibrium for HI, it's this. Calculate K at this same temp, and this is the reaction. The first thing I do is I write my equilibrium expression. So these are all gases, great. So my K is going to be products. There's no pressure units. It looks like it's all molarity, so I'm going to do Kc. And actually, it's asking for Kc. So my products squared, right? Excuse me, over my reactants. So to solve for this, I'm going to need my HI at equilibrium, my H2 at equilibrium, and my I2 at equilibrium. I have HI at equilibrium, and it's already in molarity. Great, I can plug that right in. I have these at initial. I cannot plug those in. So I need to find those concentrations when it hits equilibrium. And so what we do is we rewrite this equation and we write the letter ICE down the side. Well, this is on the next slide. I'll show you. I stands for initial. What are you starting out with before the reaction starts? C is the change as it starts going. And then E, that last column, that's, or I guess I should say row, that's what we want. That's what's going to go into your equilibrium expression. And it's kind of a puzzle. You're not always given the same pieces in this. Let's clear this out and let's set up our ICE table. Initial change at equilibrium. These blue numbers, hold on, I know you'll have to write those in, right? Initial, okay, I know I'm going to be on the ICE. And what was this? H2, I2, 2HI. I have the initial of this for my H. So here's IH. So those are going to go here. And then I have my initial for I2. It's in molarity rate, so that's going to go here. And then the other piece they gave us was equilibrium. So equilibrium of HI. So that number goes here. That's what we're seeing here. If they're not already in molarity, make sure you divide by your liters, right? Get your moles over liters, then plug them into the correct space. And let me put in my equation. Was it H2 plus I2 reversible to HI? Now this 0 means, okay, we're starting with reactants. It hasn't started yet. So if we only have the ingredients, we don't have the products yet. That's why we can put a 0 here. If I said initially I have this much HI, that means we'd be going reverse. We'd have some stuff here and no reactants. You're either starting with products or reactants. So in the initial row, whatever you don't have or is not mentioned is 0. Questions on that? Okay, then to reach equilibrium, we're going to need to consume the side that has stuff. So the reactants are going to need to go down in concentration. So we're going to show that by a minus to make the products. That's going to be a plus. If we start with products and no reactants, this side would be minus and these sides would be plus. And they're all going to change by X and a mole ratio of the X. This is a 1 to 1 to 2. So it's just 1 to 1 to 2. All right. And then that's all we have so far. So we know that 1 time, so then the equilibrium is you add these two columns. So we know that 1 times 10 to the negative 3 minus X is what we have going on at equilibrium. For my I concentration, I know that 2 times 10 to the negative 3 minus X is this. And then for my HI, I know that 0 plus 2x equals this. So in this particular problem, again, they're all going to be a little different what you can fill out, but I'm able to solve for x from this. So I'm going to pull this out and I'm going to solve for x. 0 plus 2x equals 1.87 times 10 to the third. So I'm going to divide by 2, divide by 2. And I find out that my x, what is my x? 9.35 times 10 to the 9.35 times 10 to the negative 4. Any questions so far? Seniors, it's been a long time, or some haven't seen ice tables. And honors, I don't even remember if we did ice tables because it was during like the height of the pandemic. So
we did it at the very end.
Okay. Oh my God.
We took notes on them, then we were going to apply them, and then we went into lockdown.
Okay. It's a good refresh for everyone. So definitely let me know where the holes are. Any questions so far? Okay. And sometimes we'll have it for this. Just look at it. It's I plus C gives you E. And so in this case, we can solve for X from here. Then once you get X, you can plug, this is the goal. We want this. This is what we can plug into our products over reactants. We have this one, and we could use this. Now we can solve for these other two. So I'm going to flip through the slides. So the same thing, they're just like filled in, right? At minus X plus 2X. Oh, I wrote right here. Now I can solve for X from the last column. Right? I did this, found my X. And just as a refresh, say this was a 3, then this would be minus 3x. It's all x. It's the mole ratio. Whichever stuff you start with is going to be minus, and whatever stuff you have nothing, you're going to add to it to get them to balance. So now I substitute in what I know for x. This was already 2 times x here. This was my minus x plus 2x. And we just substituted this in for x. And now we do 1 minus this number, 2 minus this number, and we can get our equilibrium numbers. And now we have what we want. We have all of these. So now we can plug them into our K expression and get K. That was the whole problem. Yeah, and then that's what the next slide will be. Yeah. So now we have enough to plug into HI squared over H2 over I2, right? Products over reactants. So we can plug this in here. Oh, sorry, that goes in here. This goes here, and this goes here, and we're going to square it. I always write my equilibrium expression first so that you don't forget to square it or cube it or something like that. Then make sure you have all of these by figuring out your ice puzzle. And this is the only thing that can go into that expression. And they have to be either in molarity or gas units. So then we plug in and we get the number 51. And this means that our, and remember it's unitless for big K. Little k, definitely lots of units. And 51 means that the products are heavily favored at equilibrium. So it's going to get to equilibrium no matter what, and the forward reaction is favored. You're going to have way more products than reactants because your numerator is much bigger at equilibrium. Any questions on that? So we're going to get lots of practice. Let's show you. Oh, let's make this live. Okay, so the first worksheet, look at this, some cleverness and problem solving skills required, you know, to set up your ice table, look into the problem. So let's just look at this one. I haven't even read the problem, and I'm going to write the equilibrium expression. All right, so looks like gas, gas, solid. So my products would be B squared times C over 1, right? Because this is solid. So you go to my K. All right, reaction below, blah, blah, blah. A is placed. Equilibrium has not happened yet. This is giving me a hint that this is I. In a reaction vessel allowed to equilibrate. After the equilibrium has been reached, the total pressure, oh, it looks like we're gonna be looking for pressure, is this. Determine the Kp for this reaction and calculate the equilibrium expression of, or the equilibrium pressure of B and C. So we're looking for Kp, it looks like. So let's do our ice. This is the solid, so don't worry about it. Looks like we started with A. If we started with A, we don't have any products yet, right? It hasn't started. 0, 0. You okay so far? Like conceptually on this. Okay. So if we started with A, we're going to have to subtract from A, even though we don't need to fill it out, to make products. So is the change for B and C going to be plus or minus?
Minus.
If we don't have any,
No, it's plus because you have to add to it.
we got to make some, right? That's okay. That's why we're going through it, right? So we're a little rusty, and it was a crazy time this time last year. So we got to make some. So it's going to be plus. So whatever side you have 0, that's going to be plus. And it's going to be X. Oh, that looks like a plus. There we go. X. X. But this one's going to be 2x. So that makes sense from your mole ratio. Okay. And I think that's all we have. Like, I don't think they gave us anything else really. So I'm going to add this so I know that at equilibrium, this is 2x. And I know this is x. This is why we say, ooh, cleverness. There's lots of little different pieces to this. This particular problem says the total at equilibrium is 1. So that means I know all of this added together equals 1, and I could solve for x that way. 2x plus x equals 1. Solve for x. And then you have the answer to what B is at equilibrium and what C is at equilibrium. And then you can plug those back into your expression and get Kp. So they're all going to be a little different. That's why there's only like a few problems for each one. So like this one says, okay, here's your equation. They're all gases. So it looks like it's 1 to 1 to 1. For the reaction below, we have 5 moles is placed. Oh, I'm already knowing we got an ice table going on. And I'm just going to go ahead and write I, C, B. What do we got? B times C over A. Allowed to equilibrate. Again, this is I. So we have I for A, if that makes sense. Can I put moles into an ice table? Nope. Got to put them into molarity, right? So don't forget to divide by 4 first. Moles over liters. Then you can put it there. And then what else we got? At equilibrium. Ooh, I like that. Pressure. Wait, hold. Ooh, oof. Okay. We've got pressure and we have concentration. We can't put in both. Let's see what we can do. Ooh. I think, hold on. We've got volume. We have pressure. We always have R. Do we have enough to do P equals under T? I'm literally like, I'm thinking, we do? Do we?
Yeah, you have temp, don't you?
Oh yeah, you're right. We'll change that to Kelvin. We always have this guy. We got this. And then they gave us this. Okay. So solve for moles and then divide it by 4. And that's going to be your E for what? B? Yeah. That makes sense. Like I literally was like thinking through, I'm like, oh, it's been a while. I'm like, hold on. Okay. So then you have enough to get KC eventually. And then use that equation we were talking about to convert the KC into KP. So this is a goodie. I know, I saw that face. So these are some good thinkers. We'll get out of class early, pretty much then. So we've got like 8 problems between the 2 worksheets. Got all weekend, okay? So that'll be due Monday for us. Some good practice on that. Questions on ICE so far? Okay, cool. Well, I'm sure we will as the weekend goes on. Feel free to email me, office hours, whatever. Okay. This afternoon, we have our rate law lab. So bring something to write with. Make sure you grab your lab packet on the way in. Grab a mask. Bring your pre-lab. And then we'll just, once everyone gets here, we'll go over the pre-lab and then we'll dive in. Should be pretty, not too bad. Let me think what else. If you're coming for session 2, remember you check in at the main high school building. Come a little bit early because you know it's kind of a walk to get over here. They'll give you a little sticker that you're clear to go, and then we'll go over the pre-lab and then you can get started. Any questions on that? Yeah, Jaden.
2 things.
Yes.
So if we're here session 1, but we're not here to do the lab, then we're doing it session 2. Do we need to get checked back in again?
Great question. Great question. Yeah. Let me clarify. If you're only coming for a session 2, you check in at the main building. If you're doing something else, session 1, and then coming to me for session 2, nope. Once they release you, you just come on over.
Okay.
Yeah. Great question. Because they'll already check you in, if that makes sense, for that session 1 somewhere else, wherever that session 1 is. Yeah.
Okay.
Good question. Yeah. So the main building's only if the only session you're coming to is session 2 lab. Okay, so for Monday, we got a bunch of outlines, some good ICE practice. We'll have so much ICE this weekend. So we got this, we got the worksheets. The main thing for you this week is your lab 10 is due tomorrow evening. Good grass, all the good stuff. And then bring your pre-lab this afternoon. And then the rest is weekend homework to work on the outlines and the worksheets. Yes, Mary Lou.
Lab 10 isn't due until like night.
5. Yeah. Yeah, I was thinking
Can you
like,
tell us like, what times do?
I was thinking 5. Does that work? Do you guys, what are you
A
thinking?
little, like,
I don't want you guys working on it like at midnight. So like 7?
Can you do
9?
I got
9?
Well, because
Yeah, or like-
people have practices too.
Oh, okay.
Yeah.
Fine. 9 o'clock. Does that work?
11?
No, because then I get in trouble for that. No, because people will be like, oh, Miss P has a lab due at like midnight. She's trying to kill us. No, we're not doing that. So 9
How about
is the latest I'll go.
Saturday. Let's go.
No.
Yeah, 9 a.m., 9 a.m., not 9 p.m.
Oh, you meant on Saturday?
Oh, like 9 a.m. Saturday. Yeah.
No.
Sunday.
You guys have had a week. No, I'm doing 9 p.m. tomorrow.
And then a flash drive, right? That we need for today.
Oh, thank you, Jaden. Yes, you need to bring a flash drive today.
Mhm.
That was really important, actually. Bring a flash drive today. You just need one. I mean, if you each have it, that's great too. Then, but one person can email it to each other, whatever. But yeah, flash drive. Don't forget that.
Roger.
Fine. 9 o'clock tomorrow. I don't want to hear. I don't want to hear you guys complain to your parents, and then I'm going to get in trouble that I make these labs due on days you don't have class at like midnight, and there's no time to work on it. No. Okay, I could have made it due today, right? If I made it tomorrow.
But like, if we put it off, that's an us problem. Like, we're gonna
Correct,
complain.
but somehow I get in trouble for that. Okay, so I agree with that. We're doing 9 o'clock, but do not wait till 8:15. Okay, we are already working on it. We've been working on it. Okay, all right. I'll see you guys this afternoon.
Mhm.
Bye.
Thank you.
Thank you.
Yeah, no problem.
Thank you.
Oh, Miss
Bye.
P,
Yeah,
can I talk to you for?
yeah.
Oh, Ms. Portillo, super
Yeah.
quickly. I don't need the office hours anymore. Kind
Oh,
of
okay,
figured it out.
cool. Can you go in and like cancel it or whatever? You have like the option, like it sends you the Zoom link on that, like at the bottom. It'll say you can like how to cancel or reschedule.
Okay, yeah, I'll cancel it. Sweet,
Okay,
thank
sounds
you.
good. No problem. Let me. There's just like what's the word I'm looking for? Auditing the class. But let's see here.